Good evening, everybody. Welcome back to another vBrownBag. I'm your host, Ken Nalbon, and tonight we are going to be welcoming Paul Mancuso to tell us a bit about NSX over ACI Fabric. Before we hand it over, a few quick notes. This is an interactive podcast. We want you, if you're watching live, to engage with us. Please use the Q&A in Zoom if you have any questions, or you can tweet to us using the hashtag vBrownBag, and we will catch your questions there and relay them over to Paul as he's making his way through his presentation tonight. If you missed this show, you come in later watching it on YouTube and want to catch any of our previous episodes, be sure to check out our YouTube channel, just vBrownBag on YouTube, pretty easy to find. Make sure to check out our other podcasts in the other time zones as well. You can sign up for any of these listed here on the right-hand side up on vbrownbag.com/brownbags. As I mentioned, I'm Ken Nalbon. I'm your host for tonight. I'll be emceeing this thing and handing questions over to Paul. But now I'm going to hand it over to Paul, who is going to share his wisdom on NSX over ACI Fabric with us. Take it away, Paul.
All right, thanks, Ken. I'm going to go ahead and open up my screen here. All right, I think I've probably done this session, I can't say, maybe somewhere under 500 times. It's obviously been updated, modified, scrapped, and then redone again, just because of the different flavors of NSX that we've had, as well as some of the discussion topic of the underlying fabric has been adjusted over time. But essentially, the discussion has been done quite a handful of times. And that doesn't necessarily mean it's just the same old per se, but at the same time, we have always perceived ourselves to be agnostic to the infrastructure, and that is why I have come to the conclusion, instead of labeling this discussion as NSX over ACI, it's just NSX over any infrastructure. And then we have, of course, a particular prescriptive setup, so a very opinionated setup of how the infrastructure should be set up, and we do so as well for ACI. So let's proceed forward. It'd be nice if it would actually go forward. There we go. So the session objective is to deliver just that, how we perceive NSX data center over any specific fabric. So we'll kind of go over our generalized infrastructure design, and then we'll go over how we see it over a Cisco ACI infrastructure. And why we see it over that is going to be discussed prior to our fabric administration and our fabric discussion. And then, of course, our laydown of NSX over ACI, we really don't have to discuss too much in that general direction. There is an NSX over any design, an NSX design in itself that lays down itself once you have a physical infrastructure set up with the infrastructure VLANs that are required for our interconnectivity between the vSphere host and, of course, NSX within that vSphere host, and then NSX edges that are going to be providing a routed adjacency to connect the NSX overlay to the physical infrastructure itself. But first, we're going to go through a little bit of our ideals of why that is so, and then we'll jump right into the design itself. Sorry, I thought I had already hit the agenda slide forward, which is what I've just described. So let's talk about it. What is essentially the role of the physical infrastructure and the software-defined network virtualized infrastructure that will essentially play the role of the application services above that physical infrastructure? We perceive the physical infrastructure as just being a very static, very stable infrastructure, so that when you build it out, it essentially should be transparent. That is our goal. And by the way, that's just not us. If you go look and do a little bit of effort and a little bit of work, you'll start to see that it's not us saying that the data center should be extremely transparent. It's essentially all of the newer startups and some of the market space beginning to say the same. That data center fabric should have zero complexity. It should be just a very rote design, simple setup, big fabric of fat pipes pushing packets in the right direction and very stable in doing so. And it's, again, it's not us just saying that. There's SmartNIC vendors already saying that. There's fabric vendors that are instituting or assuming that they're going to be successful at instituting some type of card inside of the host that will provide a fabric-less infrastructure. In other words, zero fabric at all, none even there. It'll just be something of an interconnectivity of all of the host to the tens of thousands. Or it'll be a design, something that we thought of, where we have Smart Fabric Director that will institute all of the various VLAN infrastructure connectivity requirements of the physical fabric from NSX-T. Because when you think of it, workflows within the data center shouldn't require some massive set of CCIE knowledge in order to make these two systems communicate, provide policy from L2 through L7. It shouldn't be, because if you think about it, it's all very CCNAs, to borrow a phrase from Cisco, if you will, of interconnectivity and semantics, right? We're talking about just switching, routing, load balancing, some VPN when necessary, and all of the other aspects from IPAM, DDI, and those kinds of concerns. So for me, I came up with this idea of discussing it in this specific manner. When you're talking about setting up the services layer above the physical infrastructure, what should your concerns be? Well, first off, we should look for a dynamic series of elements that are obviously going to be in play. That's that software application layer, and it's all software. That should tell you something just from that discussion alone, right? And then how do we lay down that software in a very simplified manner? Well, think of it. I want that physical infrastructure to be a very stable and solid set of service layers, so that when packets want to move between two endpoints to communicate and provide the services above it, I want it to not be complex, because I'm going to have to troubleshoot that at some point. So I did some digging on designing services, and oddly enough, I came across a large discussion on just designing architecture for manufacturing, for instance. And they came up with this concept of extracting simplicity versus abstracting complexity. So when you set up the interior infrastructure to perform some service that needs to be performed upon it, the goal should be, how do I make it simple to provide operational service layers on the underlying infrastructure without making the underlying infrastructure so complex that when problems occur, because they will, right? Somebody's going to write bad code, whether it's one vendor X or vendor Y, or some person instituting the services itself is going to perform a mistake. Somebody is going to have a problem that's going to require somebody to go and scope the problem and fix it, right? And that's that mean time to repair that we all know and obviously detest when it's extremely long, because our jobs are all on the line. So we want to extract simplicity and make it as easy as possible to lay down the functions from the top all the way into that physical infrastructure. Now, many of you may have already seen this particular slide where we have shown we're moving all of the heavy-duty operations that used to be in these discrete devices racked inside of our network environment, all of them protracted to communicate to specific elements within the physical environment. Therefore, we had to trombone communication to get all of those services to be operational, which of course is hugely problematic, lots of fun to do, and very, very time consuming when an issue arises. So our goal is to remove all of this. So instead of going through the iterative sequence of removing all of these, I'm simply going to just click the button here and just show you that our goal is to remove all of the services, whether it's ID, IPS, load balancer, the firewall, or the analytics itself, and essentially just take all of them and move them right where the workloads are being computed and the workflows are being designed for communication between each of them. And if we do so in that manner, we're essentially eliminating racks full of these discrete systems and devices, literally racks in many environments, because it's unnecessary and it's just extremely problematic. So that movement right next to where the workloads reside and where the workflows are being exercised between two endpoints, it makes it much easier to say workload A and workload B is going to provide these policies between L2 and L7 of the services layer. And there's no service graphing, no policy-based redirection, none of that. It's all very simple. A talks to B and it just gets policy. And policy for us is from layer 2 through layer 7. So as you see here, we've been building this platform for the past somewhat just under 6 years or so. And this platform was always designed from the very beginning to be L2 through L7. It didn't start that way, but it is ending, it is coming to that way, right? And with NSX-T 3.0, we have further defined value all the way through L7. And in fact, we've now even added IDS so we can provide deep packet inspection to detect those internal threats all the way to an application layer of layer 7. And again, all we have to do is write rules to enact that policy. Very simple, right? So when we talk about simplicity, that's simple. That's pushing the easy button. So let's look at a design primer of NSX-T in general. Now, most of you are probably familiar with NSX, et cetera, right? So I just figured that we try to a little level set here just to make sure that we're firmly aware of what's at the management all the way through the data plane and understand why it's all there, because that's important too. So at the management cluster layer, we have now a full management cluster that we instituted several versions back in NSX-T so that you would have high availability and failover of the management services and not just the control plane. We have a plugin series of support starting with the Cloud Services Manager, the NCP services for NSX container plugins. This gives us the ability to essentially align all of the application frameworks in an automated fashion when the management layer of NSX declares a specific intent for connectivity, policy, again, that L2 through L7 services, right? And because it is a plugin, we can essentially adapt to any new application framework in a relatively short period of time. And we've been doing so now for the past iterations of NSX-T. So those of you who have actually been on that journey with us are quite aware of that, where you just do an upgrade of NSX-T and boom, you get support for the next great new application framework that's just arrived on the scene within maybe 18 months or less as far as time frame. That's a huge short time in order to adjust to a brand new set of features in order for you to incorporate them and then leverage them in your environment. Now, getting down into the data plane itself, you see now that the ESXi host has a VDS, not an NVDS. Now, of course, we still support the NVDS because we have to do so for all of the NSX-T environments still operating on a version of ESXi earlier than 7.0, as well as the fact that the NSX-T, of course, out there is still running for the large part, obviously 2.3, 4, and 2.5 versions of NSX-T. But as you go forward, we support the native VDS, and we'll have a discussion about that in a little bit. KVM, so multi-hypervisor support. We've been doing so for many years with NSX-T. And of course, bare metal, so that you can provide bare metal support for distributed firewall services, as well as distributed network and adaptive services to bare metal functions. And now we're even adding some capability in the bare metal area with Windows Server 2016. In the public cloud, we've been adding at an extreme fast pace, right? Originally we had IBM with IBM SoftLayer, and then IBM, of course, is now just IBM Cloud, and they run a specific SDDC or an opinionated stack, but it's still primarily our SDDC stack in the IBM Cloud. We then, of course, enjoined that with VMware over AWS, so VMC over AWS. This gives us that again, that same vSphere and NSX-T and SDDC stack in an AWS cloud hosted by Amazon, right? In addition to that, we've signed agreements with Azure to deliver the very same thing. Just recently, they've just opened up their VMware services with Azure of delivering a similar SDDC stack in the cloud. Oracle signed an agreement just last year, so that'll be opening up at some point in the future. Now, those, of course, are vSphere native stacks in those particular hyperscale cloud vendors' clouds. We also have NSX Cloud that we provide operational ubiquitous connectivity from a policy standpoint and networking into Azure as well as AWS. So that's that NSX Cloud. So when you see that from the data plane, we're essentially blanketing that workload environment, no matter where it's at, in a very ubiquitous fashion from either connectivity as well as the policy. And for us, again, policy is L2 through L7. It's not just security. All right, so let's begin our foray into the infrastructure architecture itself. I don't know if we have to do this slide, but I often feel that there's just a few people in the audience at times that still feel a little bit lost when we discuss the functional elements that we require from our hosted services within the environment. We require management services. Again, we're referring to the virtual infrastructure management services. They could be hosting other services other than just NSX and, of course, vCenter. So they could be hosting services for the automation, operations, or even for the physical switch fabric. You know, we don't care. But it's a management infrastructure specific to the elements that we require for the virtual infrastructure itself, right? It could be a cluster. So I don't want you getting all concerned that it has to be a specific cluster that you siloed off in a vSphere-esque way, right? It doesn't have to be. It just has to be a functional set of elements that provide the management services. Same with edge. So the edge would be where the east-west meets the north-south from our perspective. So that east-west and north-south is the overlay that we're going to craft and discuss in a bit. That's the overlay network that will be run by tunneling endpoints over the compute clusters, and the compute clusters have to be able to communicate to a north-south barrier locality, and that's going to be where the edge is. Now, in smaller environments, I'm discussing with 3 customers alone, just this week alone, that are going to combine all 3 functional elements in a single cluster. One of the clusters is as small as 8 hosts, another one was as small as 14. So these were 3 specific things. So it was 8, 12, and 14, but still 8 to 14 was the scale ratio. And then of course, medium to extremely large, where it is obviously to the advantage of those larger environments to siphon off each of the hosted systems in a specific vSphere way, right? So you can take advantage of DRS and HA without having to use a specific set of affinity and anti-affinity rules for where specific elements of your functional environment has to be hosted upon, right? So when we speak of that, I hope that is clear to most people out there. There is no requirement to have these 3 discrete clusters. It's really more or less 3 discrete functional elements that usually end up being clusters once you start passing a certain point. And if your next thought is, well, what's that point? That really depends upon you. You know, how far you want to scale it, where you want to go. Do you feel your compute resources should be 4 hosts for management, and maybe we'll take management and edge and we'll make those the management and edge cluster, and we'll even call it M&E cluster or something like that, and then the rest will be compute clusters, and we'll simply just, you know, knock out the compute clusters as we go along, or we'll separate those because we're going to have a massive amount of management features, which NSX Intelligence and a few other ones that have a bit of a footprint to them. So we definitely want the management cluster to be siphoned separately from edge and compute, etc. You get the point, right? As far as the IP segments, again, that is more choice. Our world is that when we start talking about what is the requirements for the network infrastructure, the IP subnets that are going to be mapped to that infrastructure connectivity should, of course, be designed from the very beginning to stretch to the limits of what you feel will be your growth. So whether it's a /22 prefix, which obviously accounts for over 1,000 IP addresses to that prefix, or if it's, you know, /28, which is really only 14 usable addresses. It's up to you. All right, so be aware that that /22 is more suggestive, just to assure that you have enough space, especially if you're using a private IP space and you're not crimped in by some concerns of your environment. So this is really the same view we just saw. It's over NX or NXOS. That's Cisco's standardized operating system. It's not more the proprietary ACI fabric. It's using standard elements from an Ethernet perspective as far as management and operations within the physical fabric. So therefore, the VLANs you see on underneath that we prescribe for communication is those 4 infrastructure VLANs: management, vMotion, storage, and of course transport. And at the edge, we have a pair of transit VLANs for communication of routed services. For us, we have a few prescriptive or opinionated ideals that we would like to see. We don't really care so much about VPC on the physical infrastructure, although we just don't want to see MLAGs in general. And it's, again, it's not an anti-Cisco thing. It's just more or less along the line of, we feel that MLAGs don't really derive some benefit unless there is an overriding value that the hypervisor itself can't deliver. But since source ID or route based on source ID from vSphere usually delivers a fairly prescriptive, you know, transactional usage of the individual connections. If you have 2 connections, 1 per each of the fabrics, and it can be divvied up between them based upon MAC values, then we feel that that's fairly decent bisectional management and flow control of those, right? Or if it's communication on the edge, we definitely don't want to see VPC there, because it's not the deployment. This is the confusion that often happens at this point. It's not VPC, it's not MLAG from any of the other vendors per se, it's the MLAG in itself. It's the multi-chassis ether channel that makes it a little difficult to troubleshoot where the peering failures may be occurring, what flows from a variety of ECMP connections over that peering set of connections is, you know, is occurring, because because it's not just the issues where it's 0 value and or 100% function. It's when you have 80% function and you have to figure out why is the 20% also not functioning properly. It's, you know, it's that random set of dysfunction is more the issue. And we've seen multi-lags become an issue from time perspective of scoping your problems and narrowing your mean time to repair operations. So that's it. So I want to make sure people are aware that this is not you know, some antagonism to specifically VPC. All right.
Hey,
So I
Paul.
see that there is a question that's popped up.
Yeah. I was going to relay that to you, but I'll read it out loud for the viewers watching. So
Okay.
Britton asks, many other vendors say that they have software-defined networking too. So what's the real difference between how they apply an SDN versus NSX? Said another way, if SDN is running in a switch APIC versus a server, what's the difference?
All right. Let's envision what has happened over the past half a dozen years, because that question is fantastic, because it is exactly what we hear on a continual basis. Now, there's multiple iterations of the answer that I could offer, so I'm going to try and cut it down to just a handful, because we don't have, you know, all night and into tomorrow morning. Although I could definitely talk into that. Just give me a couple of more cups of cappuccino and I'm good to go. But to get to the heart of the answer in just a few specific select answers, first off, the dynamics of change we've seen in the past few years has been immense. I think all of us would agree to that. if you've been in this field for as long as I have, and I don't really care to say that, you know, my age, I'm 56. I don't want to care to say that age out loud, right? But when you've been in this field as long as I have, over 30 years, you've seen change that I thought was fairly quick in the 90s, a bit quicker in the early 2000s, and massively overrun in time frame in the past few years. And what I mean by that is that I remember the Catalyst switch hung around for almost 20 years, the Catalyst 6500s. And today, a switch doesn't even last 6 years, right? So why is that? Why do specific fabric items or physical device elements or these discrete appliances not last very long? It's because of the element of change has to be programmed into the way they compute and perform their function. And it can't be done in the speed that we are seeing delivered today. A handful of years ago, the speed issue was literally the issue. In other words, how fast it was, right? Went from kilobits to megabits to gigabits, and then we made that master leap to 10 gigabits. And that was huge because, you know, we've never seen that because the vSphere environment had these 1 gigabit connections across multiple links in the early 2000s, right? And most of us knew that. We had somewhere between 4 to 8 NICs, you know, on an average in a host. And today we've got 2 running 25, 40, 50, and very soon 100 and 200 gigabits. So that means we can pass a boatload of services and features and functions across those few connections. So speed is no longer the hindrance anymore. And speed isn't the hindrance also from the hypervisor's perspective because we have all of these offloads to make it essentially line rate. The NIC becomes the same as an ASIC in a physical switch. So when I was teaching switching back in the 90s, we were talking about software switching enhancements to the algorithms inside of the switch itself, the original 5Ks, and the half a dozen plus different software features that made switching efficient in those devices. Well, today's switches, we're talking about providing hundreds and thousands of hundreds of packets per second that we could never dream of doing 20 some years ago. And we can do that same performance offload in a NIC in the hypervisor because that didn't exist 25 years ago. The only place you could get that offload capability was a switch. So hence, it made sense, pump all of the features into your switch. So every time you had to do an update inside of your environment, you open the switch catalog and you pick the next revision of the switch or the current version of the day. But that's extremely expensive and very disruptive. So why not pick your switching based on 3 factors? 1, does it fulfill the performance that we've just got done discussing, right? 2, hopefully it doesn't break, because if it breaks, obviously you got to replace it. And 3, if it meets the first 2, then we could keep that switch for essentially as long as the vendor will support it, which is the 3rd criteria. How long will that vendor support it? So this gives us 3 criteria to reduce the cost of operations as well as CapEx for replacing that physical switch fabric. So then you're saying, well, I want all those services. Great, I agree with you. We should have all those services. Well, guess what? What do you think the cloud's been delivering since 2006 and starting with Amazon? That's why people go to the cloud, because the services that are delivered there are far more efficient, far more agile, far faster, and far easier to manage and get around all of the issues of getting something deployed in our environments. That's why they did that. They just open up a credit card and boom, I can go and put workload A, talk to workload B with any imaginable service that I can pick and choose through my console in that cloud world. That's what we're trying to deliver in software on your physical environment today with NSX. That's why we specify that it's not so much that the physical fabric in itself isn't of worth or value. It's the fact that it shouldn't be of the value of yesterday's legacy world. You should look at it as a stable, high-speed packet forwarding environment and let the smarts of the application services be where they are critical and where they're agile and where they're easily manipulated to bring forth new function and new value. That's all in software. Because in order to engineer a new feature in hardware, that's a handful of years ago that some engineer came up with, innovated, stuck in a chipset, and then 3 to 4 years later, bing, bang, boom, it's in a device. But bing, bang, boom is still 3 to 4 years later, not months, or within at least an 18-month cycle that we can deliver in software. And that cycle is even getting further reduced as we go forward. So Ken, I know it's a very long set of answers, but I think that covers the broad spectrum of issues that I think. So hopefully so. If whoever's asked that question or whoever wishes to ask more, please let me know and we'll go further into that.
No, yeah, that was great. Thank you for that.
All right. Now in this slide, this is truly showing the agnostic capability of NSX. I know when I stood on stage and probably told people, we don't care about the physical fabric, we're agnostic, we don't care what's underneath. And I can certainly appreciate a network engineer thinking, wow, that means my job you don't care about. No, it's not that. Remember, I'm a network engineer by heart, by trade, and my entire background. And that's how I came into VMware. I was hired based upon my networking engineering knowledge of various fabrics. That was the value I brought to the environment. But what we're saying is that it shouldn't matter about how your applications are laid down, because we should stop thinking of plumbing the applications from the physical layer up, which was the only way to do it, as I've already described pretty, pretty granularly in this discussion already. From the bottom up, we should be thinking from the top down, because that's application centric. That's the application, because we should think from the application's perspective, not from how the hardware needs to deliver it, but how the application needs to be delivered in itself. And then think, well, where can we ingrain those features in a very efficient and agile manner? Well, the cloud has already shown us where that is, and that's definitely in software. And that's where NSX has been going as far as iterative updates to the services. So we see the traditional data center fabric, which could be an older legacy model, which is essentially to this point almost disappearing. 2 years ago, I would have said 70–80% of our customers were on some type of traditional ones, and today it's tough. I mean, I would hate to give a number, but I definitely still see a handful out there. But we're already seeing people migrating off of a more modern day infrastructure that they built only a few years ago, and they may either have regretted what that modern day infrastructure was and going to a very simplified leaf spine architecture, where it's just routing, maybe a little bit of an overlay in there because they need L2 connectivity between sites. So multi-protocol BGP, EVPN is still going to be required because OTV, VPLS, and a handful of other legacy services that provided L2 between the sites just isn't something for them. So that's what the right side represents, that proprietary data center fabric that has now come up, and that's our discussion, of course, going forward. Just a little bit more on the L2 and L3 infrastructure. Just make sure you're aware, our designs cover those. So if you were to go look at our NSX-T design guide, that's what that's discussing. Exactly those worlds. Technically, the NSX-T design guide that Nimish Desai and his specific crew within VMware design and implement, and they'll be updating for NSX-T 3.0 in the very near future, but that also covers ACI. Because if you'll note in my design guide, or the design guide our specific technologist director business unit has actually put out, or I'm sorry, unit or group has put out within the business unit, if you'll notice, that design guide really doesn't go into how NSX-T is deployed. We go into a very opinionated description of how ACI is deployed, because we want ACI to be normalized to appear just like the fabrics you see here in this PowerPoint. If you have a VXLAN underlay, great. Again, we don't care. That's just how endpoints are discovered for the physical switch TORs. Because remember, it's the TORs who do endpoint discrepancy and discovery. right, and flow. The spines merely play the role of essentially a very sort of dumb high-speed backplane, if you will. Although the spines could, of course, play a tiered service to a core function, if you will, because that's kind of what the border leaves are to some extent. So we'll discuss that a little bit more detail if time permits, right? Now, I have a handful of slides I'm just going to churn through that are UCS oriented. I want to make sure people are aware, if people are interested in this, definitely discuss it to their heart's content, no worries. I taught UCS from the very first iteration of UCS Manager 1.x all the way up. But at the same point for us, we treat that blade factory set and that framework of deployment just like anything else. It's just that there is an opinionated way of setting that up, so you don't have to go into a millennia of service profiles for how you will set up your blades within that infrastructure. We do feel that the UCS C-Series rack servers are a far better platform for providing the edge, because the UCS VICs aren't so great on some of the offloads for processing. I know that's going to come as a big shock to some of you, but it's unfortunately the truth. All right, the Edge Cluster C-Series is far better because you can use any PCI enabled NIC or any of the validated NICs that will fit within a rack server itself, and you will get all of the best value of any of the offloads that are out there specifically for the edge. The UCS B series does a fine job though for our compute services, and we definitely have a deployment or a validated deployment guidance when we set up the edge inside of the UCS B series, and that's what the next set of slides will go through. So this is just showing you where we can provide the offloading of the routing and the services. This was an old NSX Datacenter for vSphere slide, just so you're aware. That's what this was actually showing. This is showing an NVDS setup with an NSX-T environment, right? So that you would have NSX-T edge VMs, and that's what the little offsetting is showing you, what that would be deployed, so that you could see that you might possibly have 2 distributed switches. That was a model that we saw with earlier versions of NSX-T. And then this is a description of the UCS FIs, of their communication upstream, because remember, the FIs play the role of a UCS domain. In fact, I'm in discussions right now with a couple of different customers, whether they're very small or very large. And so they have, let's say, anything from one domain, you know, just a handful of blades and a few chassis, and they want to divide the services functions across each of those specific set of chassis, or a huge domain. And I'm talking large. We're talking 20, 30, 40 UCS domains and more. One of them is as high as estimate to be as high as 60 UCS domains in the very near future. So their concern is, how do we lay down NSX-T in that environment so that we can leverage all of the value that UCS does, as well as the physical fabric, whether it's NXOS or Cisco ACI. Our guidance is the same prescriptive guidance, VPC for all of the east-west communication, essentially the infrastructure, and prescriptive set of trunked VLANs for the edge and the BGP routing over that edge from the FI into whatever those TORs are. All right, so they definitely could be any of the FIs that the UCS environment has had over the past several years, and of course the TORs don't necessarily have to be the 9300 series from Cisco itself per se. This here is showing the older version of where we had NSX-T. So I'm sorry I don't have a newer slide that shows our single NVDS in the edge VM, but just picture those 3 NVDS distributed switches in the edge VM edge node as being a single one. The only difference in the configuration would really be just 2 specific things. One would be the fact that there'd be a single NVDS, and 2, in this diagram here, the NVDS, this link here that I think you can see my mouse, right? Ken, you can see the mouse, right?
Yeah, we can.
All right. This link here, if we're using a separate NVDS per each of the uplinks, doesn't have to be tagged in the VLAN. So when you're doing the DV uplinks or the uplinks themselves in NSX-T and describing them for the connectivity in NSX-T, you don't have to tag a VLAN. Actually, you can't tag a VLAN because you don't need to. There's no value here, right? In a single NVDS, you would have to tag that VLAN for these uplinks. That's pretty much it. Now, I should caution you, there's one thing that when this particular design was came up, one thing I want to make sure that we note here, and it's just, you know, fair disclaimer, if you will. The transport group here, because it is only a single uplink from the edge node, and if you're not using, right, I'm sorry, I shouldn't say if you're not using. If you're using, of course, source ID here, which you don't have any choice, right? Because this is a B series blade, and the B series blade doesn't support LACP, right? Because the VPC is up here, which has nothing to do with the blade traffic per se. It has everything to do with how the bisectional traffic is managed from the FIs, but it has zero to do with how the blade itself divvies the traffic into the IO modules of the chassis and up into the IO modules here, or the FEXs here noted, and of course the fabric interconnects of the UCS managed world, right? So if this is a source ID, remember source ID means based on MAC, and there's only going to be a single MAC here. So whatever side this gets pinned to, all the traffic will go to it until it fails over or forced over for whatever reason administratively to the other fabric. I just want to make sure everybody notes that. Fair disclaimer. I hate for people to go think, oh, we're going to get usage of both sides with the TEP. Now, remember, I told you before some of the offload issues. So in essence, you're going to end up with a fairly even keel of distribution of traffic that the transport's going to be able to go line rate. So if this is 40 gig on the newest fabrics, right, the newest FIs and the latest IO modules, you're going to get near line rate capability on the transport. And because of that, the edges here are going to be able to keep up with that, all right, because they're only going to be able to pump out a specific ratio of that percentage of that transport. So in essence, it's actually not all bad that you're only getting in that regard. So I just want you to make sure you plan appropriately so that you don't underplan for your north-south and east-west communication using UCS B series, which is why we do prescribe use the UCS C series. The offloads in those can be managed much more efficiently because you can use NICs that have far better offload capability than the UCS VIX in those regard for the edge servicing. All right. Let's get right into the heart of UCS ACI. These are the alignment of the fabric access policies, right? So we're kind of jumping the gun here. I know there's no intermediary slide, but I feel like time is already becoming of an essence at this point. But think of it in this regard. UCS ACI, or excuse me, Cisco ACI has a series of objects across a set of top-level tabs in the UE, if we were to use that as our means of discerning what we're talking about in setting up in the physical infrastructure to create that normalized infrastructure of a specific set of VLANs to the infrastructure and those edge VLANs for our border routing. So remember, that's what we're talking about. That's what we're trying to set up. We don't require ACI to do anything else because it's going to create a millennium of complexity in its regard. And we've had customers come back to us and say, you're right. We went down that path, assuming that Cisco was going to be able to provide that application-centric services, and it just didn't work for us. And unfortunately, it takes them anywhere from 6 to 18 months to figure failure, and they go looking for help. Now, this isn't to say that we're always that savior, if you will, or the ones that, you know, that bail them out, but we're definitely one of the ones they go back and look to in the well and say, hey, you know, can we come out of this and figure a way out of this? So we tell them, here's a prescriptive way to set up your physical infrastructure environment based upon the ideals of Cisco ACI in the simplest manner. So remember, that's what we're concerned with, the simplest manner. Cisco ACI has these 4 basic constructs: the leaf ports and policies of the switch itself, which is really a mixture of about a half a dozen different fabric access policies, and that's what they're called, fabric access policies. All right, the attachable access entity profile, which has now been shortened to just attachable entity profile. All right, which is an intermediary, as you've seen, between the profiles of the interfaces and the switches to the domains. The domains is how you're intersected with the physical infrastructure. And then you have the VLAN pools, which is, of course, what we're trying to place upon the physical interfaces. These four discrete elements, if you will, divvied up among 15 to 30 different policies, depending upon the nature of your setup. And I do mean that specifically. It'll take dozens of different fabric access policies just to put a VLAN on interface. So we're trying to figure a way to make that as simple as possible. This is the common ACI tenant. So notice we're only going to talk about two specific overview items within ACI, the fabric access policies, which, by the way, there's something called a fabric policy. That's the communication and the management of services of the control plane within the infrastructure itself. How you concern yourself with managing it is you being the customer managing the fabric. We don't really care. We care about how it attaches to the physical infrastructure, that's the fabric access policy we just discussed, and how you craft the ACI tenant policies, which is essentially taking the fabric access policies and now activating them on infrastructure connectivity. That's pretty much what that means. The ACI tenants have a handful of default tenants. There's an infrastructure tenant, there's a management tenant, and then there's something called a common tenant. The common tenant is sometimes where people place shared services. Now, depending upon the nature of your thought pattern, you may think that's a good thing, you may not. I only put it here just to show you that it can be done. I'm not advocating one way or another. I personally don't care. It's wherever you feel it, those should be placed inside of your world and where it is best operationalized. The ACI tenant itself is the set of services that are normally enacted in this manner. We're going to show you how we enact them instead, so you don't have to have this convoluted scheme of contracts between various EPGs. As most of us know, those endpoint groups require contracts in that whitelisted policy model of Cisco, which, by the way, is fine. There's nothing wrong with that. That's actually a fine thing. But we're not going to require those because we don't really need them. We're going to show you why that is. If you follow the normal policy model of them, you're going to end up creating a series of different fabric access policies. And this is actually a small environment where you only have 4 different sets of them. All right, and then something called virtual machine management that we may or may not get into in this discussion here. And then a series of interdependent, serially dependent fabric policies. Those are the ones we just mentioned. So if we go back a handful of slides, that's these. All right, and I'm only listing just the headliners here and how you can do it in the least number of policy mannered way. And then that doesn't even include all of the object abstractions that would have to be included in this tenant. And you could see this is a recipe for disaster. This is why we tell customers this is a bad idea, especially if you're using virtual machine management, which is that unsupported ACI integration to the vCenter environment, misusing our APIs. So we tell customers, don't go this route. Essentially, something in this route, in this issue, is going to cause an issue. Remember that whole issue of whether or not it's supported by us or not. There's going to be a human error element, and you're going to have that mean time to repair set of operation that is going to be killer. And that's really the bigger problem in all of this discussion. And that's really the shame of all of this. So when I sat inside of several discussions and I heard some speakers say, oh, it's shameful that VMware won't support their own APIs. No, what's shameful is another vendor tells us how to support our own APIs. That's what's shameful. We support our APIs. We support them in the prescribed manner and the opinionated manner that we have laid them down for their use. That is important for people to realize and understand. So therefore, we don't tell another customer or another vendor how to support their APIs, but we do have a prescriptive setup of the fabric in order to lay down the services that we feel is going to be the best method of gaining a return on investment using the vSphere and the VMware stack. So it's a single set of fabric policies, a single set of ACI tenant policies, and this has all been validated. And by the way, this does not disrupt your support from Cisco or from us. So in other words, we're not prescribing a validated alignment that says you can't call either vendor and get help to the fullest extent to get root cause analysis from either vendor for any dysfunction or any mistake that's either made from a programming issue or a specific operational issue caused within the environment itself, right? So this is an old slide, it may seem like, but it's done on purpose. This is that prescriptive setup that we said that there's a handful of VLANs we require. There's our overlay that we will manage all application communication over this transport environment. A handful of ACLs are really only required then, because in an environment, management is going to require obviously some type of secure servicing into and out of it. There's no doubt about that. There's going to be something at the edge, and a vendor may still, or excuse me, a customer may still feel that there's a necessity to do something internally. That's fine. We have no real issue with that per se. The vSphere host, just so you know, does actually track and provide a firewall service within it. Most people forget that that actually exists. So therefore, vMotion and storage and transport, remember, these are all kernel level services, and there's an IP tables stateful firewall within ESXi that can provide communication filtering for its services within the environment. And since those are only going to be within the fabric, possibly between a site if they're stretched for some reason, but nevertheless within the fabric, because even if it's stretched, it's pretty much considered the same, right? And then at the edge, this is where you would definitely want some type of ACLs to discern what communication should be going into the NSX overlay and out of the overlay, but it doesn't have to be very granular, because remember, we have our distributed firewall that's going to be inlaid in a policy, automated, and in today's environment, extremely easy to lay down without having to do a whole lot of work. So at the edge, you're going to want to treat this like a provider. Certain prefixes should be here and certain prefixes shouldn't, and maybe a handful of protocols should be allowed in based on certain prefixes, and that's about it. Keep it simple, keep it light and easy, much easier to deal with the granular management of firewalling at the distributed firewall. And if necessary, remember, our edges can do the same as well. So with ACI, notice, what did we change? ACLs became contracts, because remember, NXOS and the ACI switching is the same switch. It's a switch, right? So those ACLs just became contracts because the switch is in a firewall, because firewalls don't cost $29,000, right? Or 30 or whatever an ACI Tor costs today, right? These are simply contracts implemented in a very limited scale TCAM table. EPGs, these are nothing more than endpoint groups mapped to VLANs for the various endpoints of those groupings. And of course, the layer 2 fabric, meaning that how you set up what IP prefixes are going to be used for transport, if you got IP storage, vMotion, vSphere management, you'll set that up based upon what would be the largest width on a horizontal basis of scale of hosts that you want to communicate without having to do anything extraordinary to make it happen. Because remember, you're talking about 25 and 40 gig uplinks today. Obviously, some of the folks out in the audience may still have 10 gigabits. Hopefully, nobody's still got one, but that still may exist. But nevertheless, with ACI, you're going to have a minimum of 10, because that's only what's supported on those hosts today, or TORs today. And your physical fabric has 40 to 100 to 400 of interconnectivity from the TORs to TOR, right? That physical intra-fabric connectivity. Therefore, this L2 network here that's communicating, so if we had 500 hosts communicating over a TEP, in most cases, there's always going to be the tangent you could possibly address and think of some extremely screwed up world where that might be bad, but an immense number of hosts can communicate over that L2 fabric with no issue, with no bottleneck, even though bum traffic is going to, of course, be trafficking over it. Because remember, your ACI fabric advertises its ability to do that extremely efficiently. And we have, of course, an automated control plane, all done so in our NSX management and control plane clusters that does things in a very proactive way to reduce the amount of bum traffic assistance. And we've yet to hear a customer complain about that. Most customers agree once they have actually set it up, the simplicity is the better way to go here. The outside information here is just describing all of the abstraction service or objects that need to be created. So just a handful of EPGs to meet these, right? These are considered external EPGs, so they're not really endpoint groups you create in the application profile. You create those by nature in your L3 outs in the external routing domain of your network services of your tenant. Your private networks, those are the individual IP prefixes that you will map to each individual bridge domain, and each individual bridge domain will map to each of those endpoint groups. See how easy this is? Very. So why do you need external L2? Well, that's because there may be bridge connectivity, right? There could be a very flat environment where you have application and a series of other tiered services of that application front end all the way into the database, all communicating over L2 for whatever reason, and that's fine, we support it. So therefore there would be a requirement of hopping the communication from whatever the last tier is into that DB tier that's still on a bare metal system, and that would have to be bridged inside of an NSX environment. Our NSX edges now do so at an extremely efficient rate, far better than what we did with NSX Datacenter for vSphere with NSX-T, just so you're aware of that. And of course, this would just be an external L2 connectivity setup at that same edge point location. So the ACI fabric ideal is very simple. Single tenant, few contracts, map of a series of static vSphere endpoint services into those interfaces for where you're going to do so. This is more your planning. Here, this is the actual elements you'll create, a single physical domain. We don't support the virtual machine management domain. You could have an L2 or an L3 and an L3 external domain. We just mentioned that before, but you'll have at least one external L3. Now remember, you're probably gonna have two because you're gonna have the L3 external domain that routes into the NSX infrastructure and an L3 routing domain that you're going to want to maintain separately in most cases. And in most environments, even if you're small, you're usually going to want to decide to segregate those, but just keep them in the same VRF if you're small. And larger, you may want to separate the route tables, but nevertheless, you'll have an L3 external routing domain going into the data center for inter-data center and external connectivity out of the data center, and you'll have an L3 domain that'll go into the NSX world itself. Therefore, you'll have VLAN pools to map to the usage of each of those domains, all right? One for the external. You may even have three VLAN pools. You could have, the external NSX, the external, if you will, and then an internal. But nevertheless, I only put the prescriptive set of elements that are required, not necessarily the number of elements that you have to use, okay? And then an attachable entity profile that's mentioned here, you have to have at least one, and you can't have more than one that overlaps over the same interfaces. So if you have blades, or excuse me, not blades, if you have rack servers that are operating as edge systems and they only have two NICs, two physical NICs, so now we're not talking UCS in this world, or at least UCS environments through an FI, I should say, right? We're talking standalone rack systems, and they only have two physical PNICs, and those two PNICs are doing east, west, and north-south, then you would require a single attachable access entity profile. If you're using UCS, you could get around that and then use separate VNICs, if you will, and then use one or more AEPs to provide the service interconnectivity, as we mentioned, between the fabric access policies of the leaf interface and the leaf switch interfaces, as well as the rest of the policies of the fabric access. I have another slide that shows that. An NSX over ACI tenant configuration, this is the actual tenant itself. A single tenant should not be the common tenant. An application network profile, multiple endpoint groups to serve the 4 infrastructure VLANs, the 4 bridge domains mapped to them. Again, you could use a single bridge domain. There's no requirement to separate them. It's just probably prescriptive to use them separate just in case you had some rationale for setting up the BUM assistance and the automated servicing of that within the physical Cisco ACI fabric because of some multicast feature that somehow comes out that's different someday in that infrastructure traffic or whatever have you. It's probably best just to leave them separate, that's all. It's best to leave them as a single VRF. The only reason you would separate the VRF and the infrastructure is because of your own desire. You might want them separate for whatever reason, but remember, we only require a single one for that extracting simplicity ideal. Now, the number of VRFs you have at the edge, that's completely different. All right, Ken, how are we doing on time?
You know, we're right at about an hour, but we can go a little bit longer if you got a lot to cover. I do have one question since we have a pause here.
All right, let's go
Bethune
ahead.
is enjoying this. He was wondering if there's a way to get these slides after the fact. And before you answer that, I'll just say, Bethune, don't forget, this will be up on our YouTube channel in 24 to 48 hours as well. So you can share that with your team that way as well.
I'm sorry, and this is Bethune, you said? Well, Bethune, if you meet me at a bar whenever permitted, you will get the slides for free. The payment is simply a frosty beverage, and that's simply a joke. I'm sorry. Probably a bad one. But nevertheless, I will go ahead and offer these to Ken, or if Ken and the vBrownBag doesn't have an actual SharePoint for where PDFs can be downloaded, you can just email me. You can @ me at Mancuso and Twitter. You can send me an email at pmancuso@vmware.com. Either way, I will offer you whatever assistance in slideware that you desire. So I hope that answers that, Ken. Let me know if Ken, if you do have something that you utilize as slideware to align yourself in a symmetric format with each of your shows. Okay.
I think I would recommend that folks reach out to you because who knows when they'll come across this video on YouTube as well. Hopefully you'll
Not a
still
problem.
use VMware, even if vBrownBag's method of sharing, which doesn't exist now, even if we had one, maybe long gone, who knows.
Okay, no problem, no problem. All right, well, long live both of us then, that's right. All right, so on that external network, the guide that we have today, and we're gonna see some updates. We're gonna have updates to our NSX-T design guide, and we're gonna have updates to our NSX over ACI guide, because we have obviously some huge upgrades to NSX-T 3.0. And one of them was the ability to do multi-VRF, right? Or VRF Lite. So virtual routing and forwarding instances, we can do so at the T0 edge, where we're combining multiple T0 edge nodes and deploying them as a single T0, but yet still segregating the IP route domain space. And we can do so based upon the alignment that's necessary for the customer's use case needs going into the physical fabric based upon the VRFs they wish to see coming out of NSX. So if there's 8 tenants and 4 of those tenants, or all 8, require a separate IP domain space for whatever reason, doesn't have to be an overlapping reason, just has to be separate, and they wish to see that and realize it at the common services router of that physical edge, we can now do so up to 100 VRFs coming out of NSX. The current design guide speaks as if it's all one single routing domain, so I want to make sure everybody's aware that the current one that was done in 2017, a meager update in 2018, I think I touched it up a little bit last year, but we'll definitely see some updates going forward based upon the newer features of the NSX-T 3.0 mix. But the core elements of that guide still hold today. If you just did a single VRF, the guide wouldn't have to be changed. So I just want to make sure everybody's aware of that. It's only because I want to make some validated design ideals present in the guide to follow as a reference for our customer base in case they wish to start leveraging some of the some of the cooler features of NSX-T 3.0. So to stream through a handful of slides due to time, these are the fabric access policies we require. No, you don't have to name them NSX. I just thought that would be kind of fun and cute here. But these are essentially the minimum number of policies. And I just want to make sure that people are aware of it. This is the minimum number of serial independent parent-child relationship policies in ACI, so you can map a VLAN to an actual interface of a leaf. Just want to make sure everybody understands what that actually means. So that's cool that you can do this in some intent-based fashion from the physical fabric perspective, but realize it also involves a huge amount of abstractions just to do that simple set of features. At the same point, you do get the ability to do miscabling protocol, LLDP, and a handful of others, so I grant you there is value in that regard if that suits your needs. This is the tenant that we feel is of necessity for us. This is all we need. So if you notice, no EPG to EPG contracts in this particular aspect as far as the EPGs within the infrastructure of the host. You will have some EPG contracts, as we mentioned before, for management communication coming into the host, as well as at the external EPG for the routed environment here. So that's obviously going to be required just because Cisco is going to require that. Now there are ways around that. We wouldn't recommend them. You know, you could use a handful of settings in Cisco ACI, so you can even disallow the requirement to do the white policy list or to remove the necessity to actually set up that policy requirement for contract communication between two endpoints. We would not prescribe that. All right. Now, for a multi-VRF, as I mentioned before, this is the one I was telling you. We're going to go ahead and make some updates. So I didn't do much here other than just give it a cool rainbow effect in the background here, just to make note of, you're right, there would be some prescriptive changes here for how the L3 out and the BGP adjacencies would be done on either an HA or an ECMP basis for each of the VRFs. And yes, we can do either of those on our edge node today. So I want to make sure everybody's aware of that, up to 100 VRFs. The NSX ACI Tenant, if you were to take just a snapshot of it from the interface, this would be that interface. It might be a little dated in color, but nevertheless, you still get the point. I think this is in the 4X stream. Nevertheless, I think we have up to 5.01 right now or something to that effect in ACI. All right. And this is just telling you how simple it is, right? Here's your tenant. Here's your bridge domains for the networking services. You have a single VRF. This is what's routing right now thousands of workloads in an environment. And I never have to change any of this to add 10,000 more. Never. There's no need to. So this is why we add stability to that physical fabric. And by the way, we had stability to NXOS. This would just be 4 VLANs. This would just be, well, there wouldn't even be bridge domains unless you were talking VXLAN in the NXOS fabric. And this would just be BGP adjacency set up with bidirectional forwarding detection to provide better failover of the adjacencies on an ECMP connection, right? So again, the only reason we're having this discussion is ACI does have some proprietary means of setting this up, and we're trying to inform our customers of a more normalized way to do so. Here's the L3 out detail. So it's just taking that detail down here from the external networks and then just building it out a little better. So you can kind of see a very simple setup with just a couple of edge nodes using a couple of VLANs for its ECMP connectivity. And like I said, we're running hundreds of workloads over this, but we could be running tens of thousands of workloads. The only difference would be we'd obviously add a handful of neighbor relationships for a handful of edge nodes that we would add to that edge node cluster up to the point of 8 ECMP connections so that we could take advantage of whatever connectivity multiplied by 8 nodes. This is just showing you another view of what that would look like logically, whether you're using PNICs or VNICs, and SVIs from the physical fabric perspective. So I just want to make sure everybody's aware of it. Time's kind of killing us at the moment. I wanted to get real quick to some operationals and then our operational issues, and then we're going to end our evening. Therefore, we're going to leverage a few things in the physical fabric, all right? ACI already isolates traffic based upon endpoint groups. Great, we'll just leave those endpoint groups because we don't need to do a white policy listing anymore because it already does it for us. vMotion is vMotion, management is management, wonderful. Minimal need for infrastructure changes, well, that's across any physical fabric. We're not debating that. We're simply making ACI normalized to provide that same value. Increasing workload deployment means that it's essentially a cookie cutter operation for ACI as well as any other fabric. Scaling infrastructure has minimal overhead. Ditto, same concept. Reduced hardware placement, I've already given you the 3 criteria that in my world, that's what you should be looking at. Because remember, the physical fabric itself in the data center at some point is going to see a massive transformation to something extremely simple. So whether it's smart NICs, essentially removing the necessity to have anything there, but just a bunch of high-speed pipes, whether it's a company like Rockport that's going to essentially eliminate, because they've got this idea of a fabricless physical environment, up to tens of thousands of hosts where you don't even need a switch fabric. Again, 0 switch fabric, and we can run all of our services in NSX inside of the hypervisor over that's switchless fabric, no fabric whatsoever. Smart NICs could also be portrayed where they can run over a series of white boxes or a very, very simplified physical infrastructure, or NSX-T with running Smart Fabric Director, where we essentially tell a very simplified physical infrastructure how to coordinate its VLANs and its eBGP communication to the outside world, and the switch fabric itself, the management of it, its CLI disappears. All right, so when we talk about reduced hardware placement, remember what we said years ago with ESX as far as L2 through L7, and we had just a minimal number of services 6 years ago, and the massive layering of stack. Look to see what we're saying, and we're talking about what that data center fabric should look like. All right, we're looking at and helping the operationalizing of that environment to be minimal as the days go forward. So that's that operational simplicity. That's the edge showing the ability of the environment here, whether it's distributed routing. I left this as distributed routing because it's an old NSX for data center slide, but it's still essentially tier 1 with tier 0 here. There'd really be no difference. This would just simply be a bunch of dumb forwarding routers and an NSX data center for vSphere, or very smart element tier 1 tenant-oriented routers that provide a very discrete set of functional capability in NSX-T going forward with 3.0, extremely relevant features with our vSphere with Kubernetes, as well as Tanzu Kubernetes and Tanzu Kubernetes Grid, et cetera, going forward, where the T1 plays a extremely relevant aspect in that environment. So let's not take that for granted. Therefore, the physical topology just becomes much more discrete in its implementation and operationalization, because all of the smarts are how you logically craft your network connectivity up top and how it's managed on a control and data plane in the actual hypervisor hosted world, the software-defined management world, where everything is truly software-defined, right? All of the elements that were meant to be virtualized from a network virtualization perspective, the standard that stated we wanted to take elements that were discrete appliances and place them into software-based abstractions and the physical, from the physical into the virtual, and then use a managed control plane to provide communication services over all of those systems without having to concern ourselves with all of the various proprietary extensions of every vendor, where we can just do huge amounts of valued-oriented load balancing, VPN servicing, all of the DDI and IPAM functions, and of course, the capability that we've ingrained in our firewall and L2 through L7 security services now with IDS. All right. So I'm going to leave it here and stop here, just because time-wise, as I said before, I could go on forever. I think that this is probably a good prescriptive amount of time, so we don't wear thin the patience of those who are viewing this presentation.
Hey,
And Ken,
thanks,
we
man.
can.
Yeah, that's great. Sorry, didn't mean to interrupt. Just want
No,
to
I was going
pause.
to say, Ken, that I'd like to come back and maybe do a discussion that would be sort of a part 2 of this, where we start talking more about the ideals on top of the prescriptive setup and where we can provide value to that prescriptive setup on top of what we've just discussed.
I think that's an excellent idea. So you and I will stay in touch, and we will get that on the schedule sometime in the next few weeks, probably. We got a few. Just for those watching, we've got a new vSphere 7 series starting up next week, and we'll have that for the next few weeks, and then we can bring Paul back in for some more of this NSX over any fabric, not just ACI fabric, as a future session. So thanks very much, Paul. Very great content. Really cool. Really cool. Graham says yes. Please come back and do some more. So we can't wait to see you again sometime. But we're going to call it a night for now, and thank everybody for watching.